Hello guys, welcome to my YouTube channel. So today we will be solving lead code problem third of weekly contest 368. But before starting, I have a small announcement to make. So as many of you are requesting me for guidance on interview preparation, resume review, and in normal DSA solving DSA problems as well. So for you guys only, I have created Calendly appointments. Feel free to book any appointments as per your preference. And just for your information, guys, it's totally free. Yeah, it's totally free. So you will be charged nothing, not for this session, not for any future session. Okay, so I hope you will have your doubts clear or any questions. Feel free to join that. Okay, now moving back to the question. Now, what the question was saying is, question is saying that we'll have an array nums of length n, and we want to group these. And how we are grouping it? That in one group, all the values should be same. So let's say if we have some numbers or we have some array, so let's say if we're selecting this indices and this index for one particular group, then the value at these indices should be same. Let's say if there is 2, there should be 2, and at this place also there should be 2. Okay, now what next? And now it's saying that for any two groups, the difference between the number of indices assigned to G1 and G2 should not exceed 1. So what it means was, let's say if I have a group G1 and its size is 5, and then I should have a group G2 whose size whose size must be either 5 or 4 or 6. What it was saying that the difference should be not greater than 1. The difference should not be greater than 1. So, and if we have like Gn groups, so like for any pair, their difference should be less than equal to 1. Okay, not greater than 1. Sorry, this was not greater than 1. Yeah. So the difference should be like for any Gi into Gj or Gi minus Gi. Here I am representing the sizes. Should not be greater than 1. Okay, cool. Now then what it is asking is return the minimum number of groups needed to create a valid group assignment. Okay, so this was condition for groups to be valid or the group assignment to be valid, and we have to partition the group such that these two rules are followed. Okay, cool, no issues. So how to approach this question? How to approach this question? So first of all, what we know is we have an array, right? And first of all, for any group, all the values will be same. All the values will be same. All the values will be same. Okay. Now, let's say if we want to just partition it without considering that it should be minimum number of groups, then what we can do is we can simply divide every people in size of one group, a group of size 1. So in that scenario, if we'll take any group, its size will be like for any group Gi, its size will be 1. So if we'll take the difference with any other group, the difference will always be equal to 0, right? But in this scenario, the number of total groups will be n, the total number of person we have. Okay, so we have this one solution with us, that if we take the size as 1, we'll have n groups. Now, what if we take size 2? Okay, what if we take size 3? What if we take size 4? Sorry guys. So what I'm trying to say over here is, if we have if we have like let's say 10 5 times, first of all. Okay, so what one basic intuition would be that all groups or like all 10 should be in one group, or if we are splitting into two groups, then also it will have like let's say 310 and then 210. Like we can always have a equal values, right? So what we can do is, even though we have greater number of indices allotted for a particular value, we can split them, but all the values will be same. Okay, that's one thing. Now let's say if I am saying that for any particular group it has size 3. Okay, so now if I am fixing that one size is 3, then for rest of all the groups, I know the size should be equal to 3 or it can be equal to 4. Okay, and we can also have size equal to 2, but let's ignore that because we will considering this 2. If we'll consider this 2, and then we'll take into account for 3. So for the timing, what we are doing is we are just considering that for the size of for a group of size S, we know that if we are taking that, let's say if the size of group is S, then for all other groups, the size should be S or S plus 1. Let me add. Size should be S or S plus 1. Now, if I am saying that, first of all, what we need to do is, we know that, we know that if if some value, let's say like for 3, there were 4 occurrences of 3. Okay, so what we can do is we can either put 4 in one group or we can split it. How we will split it? So let's say if I know that I have I have a number of partitions such that, or I have number of groups such that the size of each partition should be 1, the base size. Let's say there will be two sizes, right? The one will be base size, which will be like, let's say whatever the size we assign, and one extended size or like probable size or other size that can be equal to S plus 1. So in total, we'll have two sizes. For base sizes, we can have two sizes, either S plus 1 or S, because we know that the difference should be less than 1. Okay, so now what I am saying is, I want that each group the base size should be 5. Like if I am taking base size as 5, then what we can do, for all the numbers, basically what we will do, we'll store their counters. Okay, we'll store their counters. So what can it be do? This number, I know that we have to split it in such a way that either group should be size of S, not S, or S1. We know that, right? So let's say we can have 3 times S and 2 times S1. That should be equal to the this count. This count. What I am trying to say is, we already know, right? Like consider this one value. Like for a particular value, its total count was 10, or the number of its occurrences will be 10. So what we need, what we need is, either we can split it into groups such that the size of one group, or like size of any group, is either S or S1, and we know that S1 is nothing but S plus 1. Okay, so what I'm saying is, like few times S, let's say M times, or better to write it, a times S plus B times S1 should be equal to value. Are you getting it, what I'm trying to say? If I'm saying is, what I'm saying is, let's base size to be equal to S. If base size is S, then for all the groups, let's say if the count is value, or the frequency, whatever you want to say, then this value should be equal to A of S plus B of S1. Okay, because we already know that all the groups can have size S1, sorry, S or S plus 1, that is S1. Okay, now one thing is clear, and if we look at here, just this equation, we know that S is less because S plus 1, S1 is equal to S plus 1, so S is less, right? So if we want, and yeah, what we are doing over here by writing A and B is that there will be A groups of size S and B group of size S1. So if we want to minimize the number of groups, that is number of groups will be A plus B. So if we want to minimize it, doesn't it make sense that as S1 is bigger, we can have a bigger coefficient over here and a smaller coefficient over here? Are you getting what I'm trying to say? Like let's say if we have two numbers, 2 and 7, let's say. If we want to make 17, then what we can do? Or not 17, let's something, what example? I'm not able to find perfect example, but let's say if we put some value 3 over here and 2 over here. In this scenario, what we will get? 4 plus 21, that is 25. Okay, but if you will put 9 over here and 1 over here, yeah, so it will be 18 plus 7, that is will be 25. Okay, so value is same, but here how many groups are we using? This 2 plus this 3, total 5 group. Here how many groups are we are using? 9 plus 1, total 10 group. So what we realize is, if we'll have a bigger coefficient in place of bigger number, the number of groups will be less. Okay, that's one condition. So in this scenario also, what we'll do, we'll try to maximize the coefficient of S1. So what we have, like value for any particular value or for any particular number, the frequency of n, the frequency of n we are taking it as value. Okay, and it is represented as a of s plus b of s1, and what condition we have is b should be maximized. Now for this particular value, how I can find the value of a and b? I can simply run a loop for b is equals to whatever value you want. If you want to go in this way, we can simply start from 1, or it's better to start from s1, sorry, not s1, it's better to start up from value upon, let it be value upon s1. So this can be the biggest value, right? Like, if say, let's say if I am taking this as 0, then b can be at max value upon s1. Okay, it might be smaller, but at max it can be value upon s1. So what we can do for finding b, we can run a loop for I is equal to value upon s1 till I greater than equal to 1, I minus minus, and then if we we know that if for any values b of si, so what will be the remaining sum? Remaining we can write as value minus b of s1, and b is basically nothing over here, that is I. So instead of b, what we can write? We can write I over here. Okay, so value minus I of s1. So this will be the remaining value, and this should be what we have is remaining value. If we will get this to this side, this should be equal to a of s1. So for finding out a, it should be divisible by s, right? So if this remainder is divisible, remaining value is divisible by, not remainder, remaining value is divisible by s, sorry, equal to 0. It feels like it's not, but sorry, yeah. So write it this way. Then this was nothing, this is b, and if this is the scenario, that means what it means is we can represent this particular value in terms of s1 and s2 multiplied by some coefficient. So the total number of groups from here, total, let's say we are just adding it or increasing the total number of groups. So in that scenario, what we can do is we can simply add I, that is number of b, plus this remaining divided by s. So this is nothing but this was b and this is a. So in this scenario, and if we have this, then we can simply break this loop, right? Because we have to take the maximum value of b, and we are decreasing the value of I, so it will go keep on iterating. The value of b will keep on decreasing and a will keep on increasing. So overall number of groups will increase. So it's better to break it right over here. Okay, so once we have found this, we can simply break. Okay, now this was to find for one particular value, right? For one value, what we did was, like, just to reiterate, for any particular value we have to represent it as a of s plus b of s1, and we know how to find optimized value of a and b, or the best value. Okay, so for any particular value, and value was nothing, it was a frequency of any number. Okay, now now we have to also check what can be the value of s and s1, right? So for s, or better, let's say, if we have this frequency calculated, what we can do is we can simply run a loop over frequency, c over frequency, auto c, something like that. And for we can calculate this kind of value, or like the value of a plus b, and we can simply add the total groups over here. And now, but how will we determine s and s2? So listen carefully, or it's better if I'll show you the code. What I am doing is, first of all, I am creating the frequency. I hope this part would be clear. Now I am sorting that, and we are increasing the decreasing the frequency from lowest frequency. How, what I am saying is, let's say if we have initially three groups of size 3, 7, and 4, and let's say 8, we know that our best possible answer can be at least size 3 or less. We cannot have anything greater than size 3. We cannot have our base size, basically I want to say is base size we cannot have 4, because we know that at least s or s plus 1, each group should have size of s or s plus 1. And we know that for one particular value, let's say 1. So this, for 1 there are only 3 numbers which value as 1. So we know that the size of group in which 1 is there can be at max 3. So we cannot have base size greater than 3. So we know that for the starting value s can be 1, 2, dot 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 till the minimum value what we have from the frequency table. Okay, so that we have. Now we are just running a reverse loop, because whenever we find a solution, you will observe that if the base value is greater, that means the number of groups will be lesser, and if this will decrease, then number of groups will increase. So it's better to, whenever find the first solution, we can simply return it. That's what I am doing. Now there will be one question, like, we are passing the base value from here and this function check function, and I plus 1 is nothing, that is s1, and I is s. Now here it is represented as g1 and g. Okay, so and this is the vector of frequency. Now if you will see, we are running a nested loop. Here also we are running a loop. So it seems like we will have n square time complexity, but we'll come to that, because that will be nothing but big O of n. Sorry, yeah, in total it will be 10 to the power 5 only, but we'll discuss that later. Okay, now come here. So here you will see that first of all we are seeing that we assume that the value should be represented in terms of like a of s1 plus b of s2, sorry, a of s plus b of s1. So that's what we are checking, if it exists. If it does not exist, then we cannot have this kind of partition for our existing values. So we can simply return int max, or if we have, then we can return number of groups. And here we can check, if it is returned int max, that means we haven't found our answer, and we'll keep on checking. Else we can simply return our answer. Now how this will work, or why this will work? So let's say, what I'm saying is, we'll run a loop from 1 till minimum frequency, let's say m. Now we know that at max there will be n that goes to 10 to the power 5, and we know that the minimum frequency we are taking it is m. Let's say if we are taking m, that means all the other groups will have size greater than equal to m, right? If we are taking the minimum frequency as m, then all the other groups will have frequency greater than equal to m. Then the total number of groups will be 10 to the power 5 divided by m, right? And in total we will run a loop from 0 to, or like 1 to m. So in total 1 to m. So in total we will be running loop m times, and there will be total number of 10 to the power 5 divided by m groups. If you will multiply it by this by m, then overall we will have 10 to the power 5, or whatever the n we have. So in total we will run O of n number of loops. Okay, I hope this would be clear to you. If you guys have any doubt, let me know in the comment section. I'll help you out. Okay, thank you guys, and also don't forget to schedule appointment on Calendly. Thank you guys.